Welcome aboard, space crew. Today's mission takes us deep into the mysteries of the universe. So hold on tight as we blast off into the stars.
Stars literally fight gravity every single minute. Every star you see is losing a battle it can never win. Gravity is always trying to crush it, and that tension is what makes a star shine. But before stars shine, they have to survive something far more brutal. These are 15 mind-blowing facts about the stars. Number 15. Stars form violently. They form inside massive clouds of gas and dust called molecular clouds. These clouds are cold, dark, and unstable. Gravity pulls parts of them inward, gas slams into gas, and the shock waves ripple through the cloud. Matter tears, folds, and crashes as everything falls toward the center. Sometimes, the trigger comes from outside. A nearby star explodes as a supernova, sending a powerful shock wave across space. When that wave hits a gas cloud, it compresses it suddenly. Regions that were once calm begin to collapse fast. Star birth can begin because something else died. As the cloud collapses, the center heats up. Pressure rises. Material spins faster and faster, flattening into a dense core. This stage is violent, unstable, and messy. There is no light yet, only heat and motion. Only after this destruction does a star finally ignite. Nuclear fusion turns on, and the star begins to shine. And once a star is born, it usually doesn't face the universe alone. Number 14. Most stars are binary. In fact, single stars like our Sun are the exception, not the rule. Most stars form in pairs or groups bound together by gravity from the moment they ignite. These systems are called binary or multi-star systems, and they literally dominate our galaxy. In these systems, stars never sit still. They orbit each other in complex paths, pulled and stretched by shared gravity. Orbits can tilt, wobble, or slowly change over time. When stars pass close, their gravity can distort surrounding gas, dust, and even young planetary systems. Companionship in space is literally constant negotiation. Each star tugs on the other, shaping how fast it spins, how it evolves, and how long it survives. At first, this partnership can seem balanced, but as stars age, balance can break. One star can begin to dominate, pulling material away from its partner. What starts as shared gravity can quietly turn into something far less equal. Being that close changes everything, especially how a star survives its own gravity. Number 13. Stars do not burn. A star shines because of nuclear fusion. At its core, gravity crushes atoms together with such force that they fuse, releasing enormous energy. That energy pushes outward as light and heat. Gravity is always pulling inward, trying to collapse the star. Fusion pushes outward, trying to hold it up. A star exists only because these two forces are locked in balance. But this balance is not stable. It is temporary. Gravity never stops pulling. Fusion only works as long as fuel remains in the core. The moment that balance shifts, the star begins to change. Every second a star shines, it is losing fuel and edging closer to collapse. And sometimes, survival depends on more than just balance. Sometimes, it depends on speed. Number 12. Some stars spin at extreme speeds. Not once a day, like Earth, but hundreds of times faster than our Sun. These are called rapid rotators. They are born spinning quickly, or they are pushed into faster rotation by nearby stars. When a star spins this fast, gravity struggles to hold it together evenly. The star begins to flatten. Its equator bulges outward while its poles stay tighter. The shape is no longer round. It becomes stretched, almost squeezed by its own motion. Fast rotation can fling material away from the star's surface. Gas escapes more easily, especially from the equator. Over time, this mass loss can shorten a star's life by draining its fuel faster than expected. Spin also affects how a star evolves. It changes internal mixing, surface temperature, and how energy moves through the star. Now imagine adding another star into that spin. This is where things get messy. Number 11. Stars steal from each other. In close star systems, gravity can turn companionship into theft. When two stars orbit very near each other, each one controls a region of space around it, held by gravity. This region is called a Roche lobe. As long as both stars stay inside their own regions, balance remains. But stars change with age. When one star begins to swell, it can spill beyond its gravitational boundary. Yeah, aging doesn't do any good to anyone. Gas starts flowing toward its partner, pulled across by stronger gravity. One star bloats and weakens. The other feeds and grows. This transfer is not sudden. It can take thousands or even millions of years. Quiet streams of material move from one star to the other, reshaping both of them. Their spin changes, their temperature changes, their future changes. What looks like a stable pair can slowly become unequal. One star is drained. The other becomes heavier, faster, and more dangerous. Some of the strangest stellar deaths do not come from isolation. They come from being too close to the wrong partner. When stars steal from each other, the cost shows up in how fast they burn through life. Number 10. Massive stars die faster. At first, this sounds backwards. More mass means more fuel, so a star should live longer. But massive stars do not burn calmly. Their gravity crushes their cores so intensely that fusion runs out of control. These stars pour energy into space at extreme rates. They shine brighter, burn hotter, and waste fuel rapidly. While small stars can live for tens of billions of years, the largest stars may survive only a few million. On cosmic timescales, that is barely a moment. This is the mass paradox. The heavier the star, the faster it spends what it has. Power comes at a cost. Massive stars live fast because gravity demands it. Their cores are under too much pressure to slow down. Fusion races forward even when it shortens their lives. Living fast has consequences, not just for stars, but for everything around them. Number 9. Stars can consume planets. When a star like the Sun begins to run low on fuel, its core contracts, but its outer layers expand. The star becomes a red giant, swelling to many times its original size. As it grows, nearby planets can be pulled inward. Some are dragged into unstable orbits, others are swallowed completely. We have observed stars with chemical signs in their atmospheres that suggest planets were once there and are now gone. This is not rare, you know. It is a natural stage of stellar aging. The star does not chase its planets. It simply grows until they are in the way. Our own Sun will one day enter this phase. Inner planets, including Mercury and likely Venus, will not survive. Earth's fate remains uncertain, shaped by slow changes over billions of years, not sudden disaster. Stars do not destroy planets out of violence. They erase them as a side effect of growing old. But not every aging star destroys quietly. Some announce it loud and clear. Number 8. Stars can erupt without dying. These stars are called luminous blue variables, or LBVs. They are massive, unstable stars that sit on the edge of control. Their outer layers are loosely bound, held in place by a fragile balance of forces. At times, that balance breaks. The star violently ejects huge amounts of material into space. These eruptions can release more mass in a few years than the Sun will lose in its entire lifetime. Yet the star survives. One well-known example is Eta Carinae. In the 1800s, it experienced a massive outburst that briefly made it one of the brightest stars in the sky. It lost enormous material, but it did not explode. It kept living, changed, and remained unstable. These eruptions, they reshape the star and its surroundings, but they are not death itself. Not yet. Some stars scream before they die. Others just go out very differently. Eventually, though, even the loudest stars reach a point of no return. All right, crew, hold position here. Before we descend any deeper into this uncharted sector, engage the subscribe switch and signal mission control below, because what lies ahead alters our trajectory permanently. And I'd hate to continue this transmission without you. Number 7. Supernovae reshape space. They collapse. The core runs out of fuel, fusion stops, and gravity suddenly wins. The core falls inward in a fraction of a second, then rebounds with enormous force. This collapse triggers a supernova. The explosion tears the star apart. Shockwaves race outward, blasting material into surrounding space. For a small moment, the star can outshine an entire galaxy, but within a moment, it is gone, replaced by expanding debris. Inside this explosion, new elements are formed. The intense heat and pressure create heavy atoms like gold, iron, and uranium. These elements are scattered across space, mixing into clouds of gas and dust. Over time, those clouds form new stars, new planets, and eventually, the building blocks of life. Every solid surface and every complex atom depends on this process. Life is basically written into the violence of stellar death, and sometimes, what's left behind is stranger than the explosion itself. Number 6. Neutron stars defy physics. After a supernova, if the core is heavy enough, it collapses completely. Protons and electrons are crushed together, forming neutrons. What remains is a neutron star. A neutron star packs more mass than the Sun into a sphere only about the size of a city. The matter inside is so dense that atoms no longer exist in normal form. Everything is squeezed into a tight, solid-like state held together by extreme physics. These stars spin rapidly and carry magnetic fields trillions of times stronger than Earth's. Some of them emit narrow beams of radiation from their poles. As they rotate, those beams sweep across space. When one points toward Earth, we detect it as a pulsar. To understand how extreme that is, you have to understand the density. Number 5. Neutron matter is ultra-dense. A single teaspoon of its material would weigh billions of tons on Earth. That is more than entire mountains, compressed into something that could sit on your hand. This matter does not collapse further because of something called degeneracy pressure. It is a quantum effect that resists compression when particles are forced too close together. Gravity pushes inward. Physics pushes back in ways that feel almost unnatural. Inside a neutron star, matter behaves unlike anything we see around us. Nuclei are crushed together. Forces overlap. The usual rules of structure no longer apply. Scientists can model parts of this, but not all of it. We observe neutron stars from a distance, measure their mass and spin, and test our theories against them. Many details remain uncertain. Neutron stars sit at the edge of knowledge, where gravity and matter meet limits we still do not fully understand. Push matter any further, and stars don't explode at all. They vanish. Number 4. Stars can collapse silently. Not every massive star dies in an explosion. Some stars fail quietly. Their cores collapse, but the outer layers never rebound. No supernova follows. Gravity pulls everything inward, and the star disappears. In these cases, the core collapses directly into a black hole. Light escapes briefly, then stops. The star does not announce its death. It simply vanishes from view. But long before death, stars quietly reveal their future through color. Number 3. Colors indicate age. Young, massive stars burn hot and fast. They glow blue, radiating enormous energy in a relatively short life. Smaller stars burn cooler and slower. They glow red and can survive for billions of years. Their light is steadier, less intense, but much longer lasting. As for color, well, it is a clock. By looking at a star, astronomers can estimate its age, temperature, and how much fuel it has left. Blue stars live fast and die young. Red stars linger, slow and patient. The hue of a star is a visible sign of the balance between energy and time, and those colors tell a deeper story about where everything around us comes from. Number 2. Atoms are forged in stars. This might be a shocker for some, I know. Basically, stars fuse lighter elements like hydrogen and helium into heavier ones, a process called stellar nucleosynthesis. Carbon, oxygen, and nitrogen, the building blocks of life, are all produced in stellar cores. When massive stars explode as supernovae, they scatter these elements across space. Iron, calcium, and other heavy elements are carried into gas clouds, where new stars and planets form. Without this process, Earth would lack the elements necessary for life. Our bodies, the ground beneath us, even the iron in our blood, all come from these ancient stellar factories. Stars create the material foundation for everything we are made of. We are, quite literally, the product of countless stars living and dying over billions of years, which leads to one final truth about stars, no matter how calm they seem. Number 1, all stars eventually die. After burning their fuel, smaller stars like our Sun shed their outer layers and leave behind a white dwarf, a dense, hot core slowly cooling over billions of years. Over unimaginable timescales, even white dwarfs fade, losing heat until they become dark, cold remnants. Nothing lasts forever, as well say. The universe is not permanent. Every point of light we see in the night sky is temporary. But what do you think? Let me know in the comments below. And if you've still got that adrenaline high, subscribe and become a permanent member of the crew.
Our mission is complete, and we're coming in for landing. Stay aboard and join the crew again as we continue unveiling the stars.